actually Lagrange's interpolation, forward and backward and central difference operator, Newton's forward and backward, and so many interpolation are there. What is actually interpolation? Before that, we should study differences. Okay, now. Okay. So first, basic concept of interpolation. Okay. So some actually two-dimensional data will be given. Okay. You have to find one polynomial. Okay. Such that the given data should satisfy that polynomial. So f of x you have to find y equals to f of x such that x and y are given. Okay, so few data will be given. Okay, that is actually called interpolation. Okay, so different type of interpolations are there: Lagrange's interpolation, then Newton's forward and backward, Stirling, Bessel's, and Newton divided difference. Okay, difference and forward backward central difference interpolations are there. Okay, so now before we start our interpolation, first we will discuss regarding the differences. Okay, so what is first topic is finite differences. Okay, finite differences. Okay, what is finite differences? So now finite differences means some data will be given. Okay, so now we have to find, say, xi. X it will be like x minus 2. This is the notation, numbers. Okay, now maybe positive side and negative side both, and the numbering is like that. Okay, so x0, x1, x2, and so on. Okay, so these data are given. We have to find the finite differences. So all the given values, so the difference will be finite only. So now like that, the difference, if we discuss this negative part, okay, now it's okay, fine. Okay, for forward and backward difference, you can discard this part. For finite, that divided difference, you have to consider negative side part also. That means notation. Okay, 0 is the middle point almost. Okay, central difference, that 0 is the middle point, and both sides, left hand side, right hand side will be there. So right now, for initial discussion, let this part only is there. Okay, so this is the data are given. So what are the data? Now x0, x1, x2, x3, and so on. Okay, these are the data given. You have to find the finite differences. So for each x1, x0, okay, you can find, okay, you can find the functional value at that point. So that is y0, y1, y2, y3, and so on. Okay, so how we are getting this one? Now x is given, y is this one. From where? Y equals to f of x, this function. Okay, so what is the name of this one? This x0, x1, x3 are called arguments. Okay, are called argument. Point, and these are called entries. Okay, entries. So now, okay, x0 and x0 and y0, if you consider together, so it will be a order pair like y0. Okay, for this one it will be like x1 comma y1, and so on. So you can put in the order pair also. Okay, so this is the basic concept of, okay, the entries, that means values of, arguments, that means values of x, and the entries, that means values of y. Okay, so now basic definition of, okay, so finite differences. Okay, so finite differences Right now we will divide three part. One is forward differences. Okay. Next one is say backward. Okay. Backward differences. And final one say okay, central differences. Central differences. Fine. These are the three differences. Now first we will discuss the concept of forward differences. Fine. So forward differences. Okay now. What is that one? Okay. So first case, forward differences. Okay. So this is the concept. Okay. I will write here. Okay. Let us consider a function. Okay. Y equals to f of x. Okay. Define in a comma b. Okay. This closed interval. Okay. So now let us consider consecutive values of x differing by h. Okay. So consecutive values of x differing by h. Okay. So what is the meaning? Okay, differing by h. Okay, that means the values of x. This is the x, correct now? So you are considering the values of x from here. Okay, consecutive that one for each two consecutive arguments difference is h. Okay, so what will be the answer? Now differing by h, we can consider x0, x1, x2, x3, okay, xr. Okay, what is that xr? I'll write. Okay, and fine. So now differing by h, so we can write that is x0 plus h, x0 plus twice h, or else you can write this one also, x1 plus h, x2 plus h, xr equals to xr minus 1 plus h, and so on. You can represent this one in different form also. One more form I'll okay. So or x0 comma x0 plus h, x0 plus twice h, x0 plus 3h, and so on. What will be the xr? Now x0 rh. This is the answer. So the interval, we have to find the differences. Okay, but the interval a comma b is divided in this part, in this format. So this x0 is equals to, you can say a. Okay, and this is a0, a plus h, a plus twice h, a plus thrice h, and ultimately the final one, if it is there, final one, that is b. So this is the one. So you can say this one is a, and final one is, if we say xn, then it is b. Okay, so this is the division of the interval a comma b. Okay, and each 2 points, okay, each 2 points having the same distance. Okay, having the same distance. Okay, this is h. So this is the that arguments and entries. Okay, and if you find the corresponding values of y, then you can easily find this one, f of x0, f of x0 plus h, f of x0 plus twice h, and so on. I will not write. And finally f of xn. Okay, this is the, so we will not put any bracket here for the case of f of x. So this one is actually argument and this one is entries. Fine. So now what is the forward difference? So next slide I will go. So in this slide, so now the first order, okay, first order forward difference, I will write FD, forward difference of y equals to f of x. are denoted or okay, are defined as follows. So notation also I will tell you. Okay, so f of x naught plus h minus f of x naught is the first order differences, and this one is denoted by y1 minus y naught. This is the value, so this is denoted by like that. This is the notation y naught, correct? And either you can denote this one or you can denote this one also, no problem. Okay, so what is the first difference? First order forward differences. This is for first two arguments only. So similarly you can find what will be the next one, f of x naught plus h. So y2 minus y1, what will be the notation? Delta y1, fine, f of x1. So all these are, one more, okay, all these are called first order forward differences. Okay, first order forward differences equals to y3 minus y2 del of y2 equals to del of f of x2 and so on. Okay, the final one, okay, the final one, f of x naught plus nh, okay, minus f of x naught plus this one, fine, you know the bar bracket, correct now? So yn minus yn minus 1, what is that notation? Del of yn or n minus 1?
n minus 1, sir.
N minus 1, fine, good. Can we define, say the arguments are from x naught, x1, x2, xr, up to xn, xn minus 1 and then xn. If this is the argument, okay, this is the argument, okay, what is the last first order difference, first order forward difference? So this one, or we can find del of yn. What is the del of yn? Y, fine, so yn plus 1 minus yn. Do you have this one? You don't have? No. So this one we can't evaluate. So the last one first order difference is final one, that is del of yn minus 1. If you consider that x0, x1, I'm writing vertically, okay na? So x1, x0, x2, xn is the arguments of the given function y equals to f of x, and you have considered how many points you have considered here? If you have considered n plus 1 arguments, okay na? N plus 1 argument. In that case, you can find only up to yn. Okay, so I have to erase this part, last part. You can't find this one. Fine. Okay, it does not exist, del of yn for this. But if you have x of n plus 1, then you can find this one. Okay, that means if you have divided that a comma b interval into n plus 2 number of arguments, then it's fine. But our discussion is up to n. Let us see for here. Okay, so this is the case. Okay, so now this is the first order forward differences. Okay, now the second order. Now the second order, first order forward difference of this one. Okay, now the second order. Okay, second order forward differences, okay, of y equals to f of x. What will be the answer? Okay, so the second order difference is What is that one? The differences of first order differences are called the second order differences, forward differences. Okay. So in this case, what will be the answer? Now, what will be that? So that means del of y1 minus del of y0, correct, is equals to del 2 y0. This is the first one, if you consider these two. Now next two. Okay, so del of y2 minus del of y. 1 minute. Have you studied this one earlier? Okay, fine. So del 2 y1. So in this way you can find what will be the final one. So this is the notation, del 2 y0 and del 2 y1, and the differences are this one. Differences of first order is the answer for the second order differences. So now the final one. You have to answer. Okay.
Del of yn minus 1 minus del of yn minus 2.
Yeah, fine, good. Since del of yn is not there, okay na? So your second answer is correct. Correct. So what will be the final one? Del 2 y n minus 1. Fine. Or n minus 2?
N minus 2.
Fine, n minus 2. Okay. So you just check, we are actually the n minus 1 earlier for first difference, now second difference n minus 2. Okay. In that way we can proceed in that way. Okay now. So del 2 y n minus 1 you can 1 minus 2 we can find. Okay. So now what will be the third order differences? The third order differences. So these are the second order differences. Okay now. Differences of the first order, of course consecutive, okay now, is called the second order. Then what is the third order differences? So instead of this one, now third order differences. Then I will stop. Okay now. So just wait. Before that, okay, new one. So now del 2 y0. What is that one? Previous one. Del 2 y0 is del of y1 minus del of y0. Correct. So del of y1 minus del of y0. Fine. So this is the definition. Now if we expand it, what is this one? Del of y0, y1. Am I correct? This one. So ultimately del 2 y0 is this one. Fine. Now you just tell me what will be the answer of this one. Till now we are discussing second order differences only. So del 2 y1, what will be the answer? Fine. If you check the coefficient, 1 minus 2 1, 1 minus 2 1, this is the coefficient of a minus b whole square. What is the answer? Fine. The coefficient of a plus b whole square, that one. So this is the fact, del 2 y n minus 2. What is the answer? yn minus 2 yn minus 1 plus yn minus 2. Fine. So this is actually following the binomial expansions, coefficient of binomial expansions. Okay, fine. Next, third order differences. Next one is third order forward differences. Okay, so now third order forward differences of y equals to f of x. Fine. So what will be the answer? The answer is the differences of second order forward differences is known as the third order forward differences. So del 2y1 minus del 2y0. Fine. This is the answer. So now what is actually del 2y1 and del 2y0? Okay. Previous one I will go back. Sure. So the difference between these two consecutive, okay now, or difference between these two is the difference of third order. So now we will go back. Fine. So del 2y1 minus del 2y0 is the del 3y0. Okay. So you have to just tell me this one. In the next page I will write. Okay. So the answer for this one, next one, is equals to, okay, tell me the answer. This one minus this one. So del 2y1 is y3 minus 2y2 plus y1, and del 2y0 is y2 minus 2y1 plus y0. Correct. So if you simplify it, then it will be 3y2 plus 2y1, 3y1 minus y0. Okay. So del 3, the third order differences y0 is this one. So what about del 3y1? y4 minus 3y3 plus 3y2 minus y1. Fine. And actually this one is nothing but del 2y2 minus del 2y1, and that is the expansion of the earlier one. Okay, earlier one is the expansion of this one. You have noticed that the third order differences, the coefficients are 1, minus 3, 3 and minus 1. Okay, so that coefficient is the coefficient of a minus b whole power 3. Correct. So this is the forward differences. Now you can similarly we can find higher order, that means higher order differences you can find. Okay, you can find the others also. Okay, so in that case you can find similarly del 4 y, I will not write y0 or 1. Okay, you can find similarly del 4, del 5 and so on, you can find. Okay, so now next one is backward differences. Okay, sorry, before that, how can you find this one? Very simple and easy way. Okay now, so for that you have to construct a table, okay, which is known as forward difference table. Okay, so two types of tables are there, one is diagonal, one is horizontal. Okay now, so table I will write, okay, diagonal forward difference table. Okay, so the arguments are say x0, x1, x2, x3. That's enough. Or okay, final one is x5. How many arguments are there? 5. Correct. So this is the x, this is y, first difference, second difference, third difference, fourth difference, fifth difference you can find. and so on. Okay, so now respective value of this one is say y0, y1, y2, y3, y4. So what will be the that first difference? Okay, you can place this one diagonal table, so in between this one, okay, middle of this one, so you put here, okay, y1 minus y0, and the notation is del of y0, correct, del of y0. Okay, so I will write once again. Okay, so in between middle, so del of y0 equals to, okay, y1 minus y0. Here it is del of y1, del of y2, del of y3. You know the formula. Okay, y1 means y2 minus y1 and so on. Okay, so now how to find del 2 y, and you have what will be the position to entry that value, that one you put it here. So del 2 y0, del 2, okay, y1 in between, del 2 y2. Now del 3, so del 3 will be like here, del 3 y0, okay, del 3 y1. Now del 4 will be in between that one, okay, in the middle of this one, so del 4 y0. Okay, you can find. What about the del 5 y0? Sorry, del 5, what will be the entry? There will be no entry. Okay, now you can't find that fifth order differences. So you can't find these fifth order differences for these arguments. How many arguments are there? So what is the maximum order you can find? Fine. So if n numbers arguments are there, then what will be the final? Yeah, n minus 1th order up to that one you can find. Okay. So this is the diagonal forward tables. Okay. We will not write that horizontal one. It is actually, it will not place. It is looks like diagonal. What is that one? So this table is like this form. Okay. Okay, this is the form. The another table, it is the same concept, same differences. It will be placed like this one, and it will go up to this one. So this is the form. Okay. So this is the this way. Okay, so I will not write that one. Okay, so that is known as horizontal. Same entry, instead of middle you have to put here. Okay, now so del of y0, del of y1 parallel. Okay, now del of y2, del of y3. So ultimately all this will fill. Okay, now it will not go in that way. Okay, now so finally, okay, sorry, it should be here. Okay, now so similar way the entries will be like that. Okay, this one, this go that circles are the entries, and then final one, there is nothing. So that table is actually horizontal table. We will follow, we will use a diagonal table only. Okay, so this is the okay, diagonal or simply forward difference table. Okay, next topic is backward differences. Okay, backward difference table. Okay, so what is the backward difference table, or what is the backward differences? First of all, backward differences. Okay, so now the same, almost similar one. Okay, only the notation will change and some little bit concept. Okay, the difference of f of x0 plus h minus f of x0, the notation is y0 minus y1 minus y0. Okay, this one, this type of differences. So now next one is f of, okay, x naught plus twice h minus f of x naught plus h. So this is y2 minus y1 and so on. F of next one is f of x naught plus 3h minus f of x naught plus twice h. So y3 minus y2 and so on. Okay, these are the differences, okay, are called first order backward differences of y equals to f of x. Yeah, both are same. Okay. Only notation will change, and that's why ultimately the difference I will discuss. Okay, now just wait 1 minute. Okay, so y1 minus y0 and so on. Finally, the final form, if it is say n number are there, so f of x0 plus nh minus f of x0 plus n minus 1 h. Again, some problem. N minus 1 h is y n minus y n minus 1. Fine. So these are the say difference. And if the notation of this one, if you consider nabla y1 instead of del y1, this is called backward differences. Nabla y2 and nabla y3. Final one is nabla yn. Okay, so this is actually reverse of del, correct now? So these differences actually nabla of y1, nabla of y2 and so on yn are called, okay, are called backward, sorry, first order, okay, are called first order, okay, backward differences. Fine. And notation already there. These are the notation, and the notation is, what is the notation? I have already discussed. This is the notation for the, this is the notation. Okay, the notation is this one. So now you can check that one. Okay, as your friends already pointed out, this one. So what is this one? Now y1 minus y0. What is this one you have studied just few minutes back? What is that one? Del of y0. Okay. So if we are here, then you can easily identify that. Am I correct? So what is the final one? Nabla of yn. What will be the delta? Del of y n minus 1. Fine. So this is the backward differences and the forward differences relation. We will generalize it in the next slide. Okay now. Before that, okay, these are the first order differences. So what is the second order backward differences? The differences of first order backward differences is called the second order backward differences. So I will write here. Okay now. The second order backward differences are, so nabla 2, what will be the answer? You forgot about the forward. Okay now. Now from the backward, you tell me what will be the answer. I can write nabla y2 minus nabla y1. What will be the answer? I have not written here something. So this question mark is actually missing. You have to write here something.
Y2.
So nabla 2, huh? Oh, yeah, correct. Nabla 2 y2, this one. So nabla 2 y3, nabla y3 minus nabla y1 y2 and so on and so on. This is the second order backward differences. Okay, and similarly you can find the higher order backward differences. Fine. So I will just write in the next slide, then next slide. Okay, so the backward differences. Fine. So the backward differences are del 2 y naught. What is the answer? Sorry, nabla 2 y naught.
They does not exist.
Does not exist. Good. Okay. Does not exist. What better? I just explain it why it is does not exist. So the answer should be like that, correct now? Y naught minus del of y1, fine, or minus 1, correct now? So go to the previous slide. So del 2 y naught or del 2 y1 if okay. So starting and then one less, correct? So next one is this one should be minus 1. This nebula of minus 1, we don't have y minus 1 form. We are starting from y naught. So you can't find. What about nebula to y1? So the answer is nebula y1 minus nebula y naught. This one also does not exist as per the, you just see starting from nebula y naught, oh sorry, y1. The formula is y1 minus y naught. So if you go there, so the answer is y1 minus y naught. It is exist, but minus of, okay, minus of y naught minus y minus 1. This one does not exist. So even this one does not exist. The second difference also does not exist. So it is starting from del 2 y2. Fine. This is the starting. So this is the starting nebula 2 y2. Fine. So what is the answer? And nebula y2 minus nebula y1. So that is y2 minus y1 minus y1 minus y naught. So that one we have already discussed. Okay, 2y1 minus 2y1 plus y naught. Yeah, exist. All the entries are exist. So what is the first second order differences for the arguments? Okay, starting from y naught, sorry, x naught, and so on. That means the entries y naught, y1, y2, and up to yn, say. So what is the first for a second order differences is the backward differences is this one. What about the last one? Like forward differences, we have already checked that we can find. Just wait, I will show you. So if it is 4 are there, sorry, 5 entries, 5 arguments are there, okay, then you can find up to 4. Okay, so that is now this one. Okay, for this case, what will be the answer? So starting with this one, what will be the end one?
Nebula 2 yn.
Yeah, yn minus 1. So for this case, actually the starting will be not there, but end will be there, correct now? So
Yes,
ultimately you can find that one. Okay, so in this case n minus 1, or you can find n minus 1, fine, that one. So the table is similar. Okay, so I will not draw any table. So the similar case, backward difference table. Okay, you can find the backward difference table also. Okay. Okay, now one example of this one, backward difference and forward differences table, how to prepare the table. Okay, now so right now. Okay. Okay, so example. Okay. Okay, let us consider, should have at least okay, let us consider a set. This one is very simple one, set of values. Okay, set of values of a function f of x as follows. Okay, so the values are this one. 0, 1, 2, 3, 4. Okay, 2, 3, 12, 35, 78. Find the backward difference table and forward difference table. Okay, quick. So, and all should be diagonal table. Okay, no problem. So, odd roll number, even roll number. Okay, need to answer quick. So the table will be like that. Okay, solution. So you have to write if let us consider the forward difference x, y, del 2y, del 3y, and so on. I will write later on. Okay, now 0, 1, 2, 3, 4. Corresponding value is 2, 3, 12, 35, 78. So if it is diagonal, so 1, 9, 3, 23. Next one is 3, 4, 43. So this one, find it quick. So this is the it is 8, correct? So 23 minus 9, 14. Next 20, correct? So this one is, what is the answer? 6, correct now? 6, 6. What about del 4y? 0. So it is 0. Okay. And you can't find del 5, that is fine. But even del 4 you can find, then also it may be 0 or some other values. Okay now? So that possibility is there. Okay. So this is the table, forward table. You can find the similar way the backward tables. Okay. So let us see from our discussion till now, we can find the relation, okay, between the backward and forward, okay, relation. So what is the relation? The relation between, okay, the relation between del and nabla. Okay, so I have written first nabla then del. Okay, okay, let us see. Y3, what is the answer in terms of del? I should answer immediately. Del y2. I have already written that one already. Okay now. So now del 2 y2. Okay. What will be the answer in terms of nabla? Next one is different. The nabla 3 y5. What will be in terms of delta? Anyone? Why? No, this side, del 2 y2 equals to, in terms of nabla, nabla y2 y3. So okay, I will check, Hana. So now nabla 3 y5. Delta 3 y4 or something.
Y3 sir. Y2 sir.
Y2. Okay. Okay. And so on. Fine. So now if we write nabla 4y2 is equals to, sorry, del 4y2 equals to nabla 4y6. Okay. So now I will write the general form. Say del I y, okay, equals to nabla I y. What will be the coefficient of y? This coefficient, this coefficient. Okay, I'll write. Okay, now. So the answer is, say, yj, correct? Yj. Now you tell me this answer. Here it is actually some mistakes are there. This is 4. This is 4. These are the rest are correct. So it is actually, this is, it should be, I will write. Okay, now. The relation between, you can easily prove it also, no problem. The proof is very simple. Okay, I plus j. Okay, so this is true for all ij. Okay, so this is true for all ij. So del I yj equals to nabla I y I plus j. This is the relation between the forward and backward differences. This is the relation between forward and backward relation. Okay, sorry, differences. Fine. So now you can check it. So next one is properties of del, and the properties of nabla also you can evaluate. Then after that, no problem. Okay. So now let us see from your difference concept. Very simple. Okay. Say the function f of x equals to, why I am writing there. Okay. Say f of x function is c. Okay. Then what is the differences, forward differences for any point?
0.
Yeah, y2. Yeah. For any point yi, okay, is 0. Means say the point is x1 and x2, 2. Function value is always c. So del of, for example, okay, y0 minus y1, sorry, del of y0 is y1 minus y0, c minus c is 0. Okay, fine, good. So this is now, okay, say the function is not constant, but the function f of x is, say, x square, and another function f of x, say, 5 into x square. So what is the difference between these two functions? That is, one is 5 times of another one, correct now? So f of x or g of x, we can write this one, f of x is k times, that means k equals to 5. So k times of the another function. Okay, if that is the scenario, okay, what will be the differences between the forward differences? Okay, so now you tell me this one, f of x you might be knowing. Okay, now, so what will be the del of k into f of x? So what is the difference between this one and this one? So forget about this one. The answer of this one is k times del of f of x. So k is a constant. Fine. So if you know the differences of x square, y equals to x square, so no need to find another table for 5x square or minus 5x square. Fine. So that is the scenario. Okay. So third properties of del. Okay. It is actually following the distribution. That means actually it is following the arithmetic operations, plus and minus. Not regarding plus, I will discuss the product. So del of, say, function f of x plus g of x plus h of x, 3 function. Okay, what will be the answer? you can take separately and then you can add. Fine. H of x. So since it is true for 3, it is true for n number of functions. Okay. And this arithmetic operation, that means negative arithmetic operation, that means subtraction also satisfied. Okay. So what is the answer? No, arithmetic operations. Okay, first then you take the forward difference, or else you take the forward difference and then you find the that arithmetic operation, that is also fine. So now fourth one. Okay, 2 times if you want to find. Okay, what will be the answer? So you can do this one in that way. Correct. So what is the general form? Now m times and del of n times on f of x is nothing but m plus n f of x. This one. Okay. The final one, I'll erase the first one, otherwise I can't write actually. The space is not there. So this is the final one. What will be the final one? So fifth one is like that. So del of f of x by g of x, provided that g of x is not equals to 0. Provided that, okay, g of x is not equals to 0. What is the answer? Yeah, fine. So del of f of x by del of g of x. Okay, I'll just okay, this is fine. So now what is this one? I have written something. What is that? D, correct? Yes or no? Wait. What is this one? Differentiation. Fine. D, you have not used earlier. D, capital D. D is the operator. Which type of operator? Well-known operator. Differentiation. Fine. And now f of x divided by g of x. What is the answer? No need to ask. Correct now? You know that one. Fine. Yes or no? Yeah, fine. So it's not like differentiation of f of x upon differentiation of g of x. Correct? So here also a little bit difference. Okay, na? Fine. Okay. So into g of x. So it is outside. So g of x minus f of x into g of x. What will be the down one? That means denominator one. Yeah, but correct. Okay. So no problem. It's fine. You have actually try to answer this one. That's best. Okay, now that's good. Okay. So now this is the answer. Correct. What is the answer? Now g of x operator on f of x minus f of x operator on g of x divided by g of x into one increment of g of x, that is g of x plus h. Fine. So this is the formula for the that is the division of two functions f of x and g of x, and if you want to take the operator del, this is the formula. Okay. So now, okay, now we'll check what you are doing. Okay, everyone, you have studied a lot of things. Can you prove? So one example, say one more, or prove that. One problem you can say. Prove that. Okay. Prove that del dot nabla equals to del minus lambda. How to prove that one? Okay. So take left hand side or right hand side and then prove it. Okay, now proof of this one. Okay, as we know that, okay, we know if del of f of x, that middle dot came, man, del of f of x. What is the answer? F of x plus h minus f of x minus h. Huh?
F of x.
F of x, fine. F of x. Okay. So, and nebula of f of x, nebula on f of x. What is the answer? I will write then.
F of x minus f of x minus 1.
X minus h.
X minus h.
Fine, fine, good. So now left hand side, okay now? Okay. Del dot nebula. So on f of x, what is the answer? Now del on this one, okay, f of x minus f of x minus h. So what is the answer? Now del of f of x, arithmetic operation is actually permissible, admissible, okay na? So what is that one? F of x plus h minus f of x, fine. Okay, minus sorry, minus, okay, what is the answer? Del of x, that is x minus h. Tell me this one, what will be the answer? Okay, right, okay, I have done one. Since this is our target, I have already fine. Our target is different, so we'll write del of f of x as it is minus, okay, f of x minus f of x minus h. We can write this one, correct? This one. So now from the definition you just check it. Del f of x minus nebula f of x. Okay, del f of x and nebula f of x. Okay, so therefore, okay, therefore del dot nebula, so this one we can write here, del minus nebula on f of x. So therefore this one is del minus nebula. Okay, now I will give two problems for practice purpose. Okay, now problem 1. Okay, then I will go to the next one. Okay, problem 1 is, so this one, prove that del power n, okay, x to the power n, okay, is n factorial h power n, where this is what, this notation, x into x minus h, x minus twice h, and up to x minus n minus 1 into h. This one, problem 2. Okay, prove that del of n plus 1 x power n, this notation same, is equals to 0, where you know that what is, where x n, you know what is the answer. Just previous one we have written, or else if you have doubt you can write here itself, x minus 1, x minus 2, dot x minus n minus 1 bar this h. Okay, fine. Okay, next, okay. Next one, page 1. So some relations, okay now. relation between del and d. What is d? Derivative. This one, fine. D by dx. Okay. So now what is the difference? Relation between del and d. If you are able to find that one, then you can easily find the d and del, since you know the relation between del and nebula. So now we are finding del and d. If that relation is known to you, then you can easily relate between these two. Okay, now what is the relation, and so on. Fine. So now proof. Okay. Relation. So what is the relation? So what is f of x plus h? So now can you write this one, the Taylor series expansion, okay, or Taylor's theorems? What is that one? Anyone? Expansion? F of x plus h equals to, tell me quick. Are beta, Taylor series expansion, you know? No, I am helping you. Okay, now you just tell me. F of x plus x. Yeah, 1 factorial. I will not write it. I am not writing here. Okay, since you are telling, I will write. Okay, now next. Fine. No need to write anymore. Correct now. This one. Okay. So now one relation is there actually. That one I have not yet discussed. Okay. So okay. It will be. You have any class? Next class? No. Can I continue for another hour? Another half an hour?
Yeah.
You have class? Sure,
Yes,
na?
sir.
But I will check. So you have class Friday. Hey, you have break na? Up to 10:30.
Completed, sir.
Oh, 10:30 completed. Okay. Okay, then next class I will discuss this one. Why? We have to discuss some other operator also. Then only we can find this relation. Yeah, up to this one is fine, but okay. In the next class we will discuss this one. So these are the homework. Okay, you try to do this one. Okay.